Good morning. Our lecture today is Introduction to Econometrics. What's econometrics? Econometrics represent the application of mathematics and the statistics to economic crude data in such a way an economic phenomena is analyzed quantitatively. So this means that econometrics is a connection of statistics, mathematics, and economics. So the point of connection of the three subjects together, this is econometrics. Methodology of econometrics has certain steps. This means that in order to perform an economic analysis, an econometric analysis, a number of successive steps should be followed. Step number 1. Identify theory. Or hypothesis. Say, for example, you would like to study the relationship between quantity demanded of any product and its price. So according to economic theory, there is a negative relationship between quantity demanded and the price. So this is the identification of theory. We would like, another example, we would like to study the impact of investment on economic growth rate of the country. So according to economic theory, there is a positive relationship between investment and economic growth rate, etc. So this is step number 1. Step number 2, is to specify the model in a mathematical form. So returning back to our example, which studied the relationship between quantity demanded and the price. So we can write the mathematical form in this case as QD equals A minus PP. So this is step number 2. Just to write the economic theory or the hypothesis which you would like to test in a mathematical form. Step number 3. Convert to econometric form. The main difference between the econometric model and the mathematical one is the error term. So if we write the mathematical form as y equals b naught plus b1 x, so this is the mathematical form. If you would like to convert it to an econometric form, this means that we are going to write it as y equals b naught plus b1 x plus u, where u stands for the error term. So the main difference is the error. This means that the econometric form is an approximation for reality or the average values. Later on, we are going to explain this in details. Step number 4 is to collect actual data. This means that we are going to collect data for the two main variables. Returning back to our model, y equals b naught plus b1 x plus u, where y is a dependent variable, which means that its value depends on the values of x's. Okay, so x is an independent variable, b naught and b1 are parameters or coefficients, and from mathematical point of view, b naught is the intercept, which is value of y when x equals 0. b1 is the slope, which is a change in y due to change in x by 1 unit. And u, as we said, is the error term. b naught and b1 are constant values, while y and x are variables, which means that they have different values over time or across number of observations. So we have to collect data for y and x. But what are the different types of data? that can be collected. There are three main types of data. Number one, time series data. Which means that we are going to collect data over time periods. For a single cross section or sector or country. So, for example, we are going to collect data for the Egyptian economy. So this is only one cross section, which is Egypt, over the period from 1990 to 2021. So this is a time period for only one cross section. The time series data can be annual data, or semi-annual, or quarterly data, or monthly, or even weekly data. The second main type is the cross-sectional data. This means that we are going to collect data for number of cross sections. At a certain point of time. For example, we are going to collect data for a number of developing countries in 2021. So this is number of cross sections at a certain point of time, which is year 2021. The cross-sectional data can be for different countries or different sectors or even different individuals. Number three, panel data. Panel data is data for number of cross sections over time period. Say, for example, we are going to collect data for developing countries over the period from 1990 to 2021. So it's like a combination between time series data and the cross-sectional data. So in step number 4, we have to identify whether our data will be time series or cross-sectional or panel data, and then collect data for these for the variables under consideration. Step number 5 is to estimate the parameters or coefficients. For simplicity, as we said that we would like to study the relationship between quant demanded and the price, so we have to collect data for quantity demanded and the prices, different quant demanded and the prices, or at different time periods, or across sections, across different countries, or panel data. Anyway, this is the variables that the data that should be collected for the two main variables. And then we have to estimate the parameters to find the value of the parameters, which means we would like to write the equation as QD equal the value of the estimated value of the parameter is 100, for example, minus 5b. So this means that we have estimated the value of A and B based on the collected data for B and Q. Step number 6 is to test the significance of the estimated parameters. We would like here to test the significance of the estimated model. Test the significance of the model will be divided into two main parts. Number one, which is related to the parameters, and number two, which is related to the model itself. With respect to parameters, we would like to identify whether the value is based according is calculated according to the economic theory or not. Say, for example, the relationship between QD and price should be negative, but according to our estimation, it's a positive one, not negative one. So we have to identify why, whether there is a estimation problem or we have a reason for this problem or this result. Also, sometimes according to economic theory, the value of the parameter should range from something to another. Say, for example, marginal propensity to consume. The value of MPC should be greater than 0 and less than 1. But if it's based on our estimation, it's 1.5, so it's something weird. So we have to identify why it is 1.5. Maybe we have a problem in our estimation. So this is part number one, which is related to the parameters. Part number two, and this is going to be done by t-tests. Part number two is related to test the significance of the model. With respect to the model, we would like to identify whether it is follow the functional form, is a correct functional form or not. Is there any problem related to misspecification of the model, which means that we ignore one of the most important variables or add any unimportant variables. Significance of the model can be represented by R squared, or known as coefficient of determination. And F test, which tests the significance of the model as a whole. Mainly, we would like to test the model in order to explain the reality and to do two more steps. Step number 7 is to use the model for forecasting, which means we would like to predict the future, the situation in the future, what's going to happen in the future. And step number 8, it is related to draw policy recommendations. Actually, we would like to study the relationship between two variables in order to identify or to achieve number of objectives. So as a result, policymaker can use um, this model in order to make recommendations to achieve the main objectives under consideration. So these are the 8 main steps that should be followed in order to perform an econometric analysis for any relationship. Actually, in economics, all variables are interrelated with each other. So economic models involve relationships among variables in order to define and or explain one or more of these variables. But how do we understand a relationship? To develop and understand any relationship, we have to answer a number of questions. Number one, what are the variables under consideration? So we have to identify what are the variables we would like to study the relation between them. Number two, which variable needs to be explained? Explained means dependent. And which one is the explanatory variable or the independent variable? Number three, is the relationship between the two variables is a positive or negative relationship? Number four, how much will be the value of the dependent variable if the value of an independent is zero, which is the value of the intercept? And finally, question number five, by how much the dependent variable will it change? If an independent variable it changes by a small amount, usually 1 unit. So these are the 5 main questions that should be answered in order to identify any relationship between two variables. So let's take an example. Question number 1. What are the variables? I, which is the investment, and Y, which is GDP. Question number 2. Which variable needs to be explained? I is the variable, the explanatory variable, the dependent variable, or the variables that need to be explained. Question number 2, the rest of question number 2, which variable is the explanatory or the independent variable? GDP is the independent variable. Question number 3, is the relationship positive or negative? So here the relationship between investment and GDP is positive relationship. Question number 4, what is the value of the dependent variable? If the value of the independent is 0, it's 50. And finally, question number 5, by how much the dependent variable would change if the independent variable change by 1 unit? It's 5. So this is the 5 main questions in order to study or to identify a relationship between two variables. This is the end of our lecture today. Thank you and see you next week.